this session we shall see some problems on properties of triangles. First problem, in a triangle ABC, if R into R1 is equal to R2 into R3, then the triangle is, first option, equilateral, second option, isosceles, third option, right angled, and fourth option, scalene. Now what are these R, R1, R2, R3? Let's just have a look at this. Let's recall. You have a triangle ABC. R is the radius of inscribed circle. This is R. R is the radius of inscribed circle. You have three ascribed circles, that is touching all the sides ABC but external. This is the ascribed circle opposite to the vertex A. This radius, the radius of this circle is R1. Similarly, you have an ascribed circle opposite to the vertex B. The radius of this circle is R2. R2 is the radius of this circle. We have one more ascribed circle touching this X. Alright, we have one more circle like this. The radius of this circle is R3. Now we have formulae for them. R is equal to delta by S, where delta is the area of the triangle and S is the semi-perimeter. R1 is given by delta by S minus A. R2 is given by delta by S minus B. And R3 is given by delta by S minus C. Okay. Now, what is we will find? We observe that R into R1 into R2 into R3 is equal to delta square by S into S minus A into S minus B, delta power 4 by S into S minus B into S minus C. But the denominator is again, what is the denominator? The denominator is delta square. So it becomes delta power 4 by delta square. So which will be equal to delta square. This is one of the important observations on R, R1, R2, R3. Okay. Let's keep this in mind. And we also have 1 by R1 plus 1 by R2 plus 1 by R3 is equal to 1 by R. This is quick to verify. 1 by R1 plus 1 by R2 plus 1 by R3 is equal to 1 by R. So, and moreover here, if you look at this R into R1, it is delta square by S into S minus A. Whereas R2 into R3 is equal to delta square by S minus B into S minus C. Now let us consider RR1 by RR2, R2 R3. RR1 by R2 R3. From here we will get that is equal to S into S minus A by S minus B into S minus C. That's clearly tan square of A by 2. We have the half angle formulae let's recall the tan A by 2 formula is root over S into S minus A by S minus B into S minus C. In this context, let's also recall sin A by 2 half angle formula is root over S minus B into S minus C by BC. Cos A by 2 is given by root over S into S minus A by BC. So, very clearly, if you divide one by the other, sin A by 2 by cos A by 2 will give me S minus B into S minus C, right. Here the reciprocal has been written here. So, it is actually RR1 by RR2, R2 R3 is equal to delta square will have S minus B into S minus C by S into S minus A, which is actually tan square of A by 2. So, R1 R by R2 R3 is tan square of A by 2. This is a formula that we know. Okay. In this context, in the problem given, RR1 is given to be equal to R2 R3, which means that tan square of A by 2 has to be equal to 1. So, tan square of A by 2 is 1. Hence, A by 2 must have been 45 degrees. So, A must have been 90. Therefore, the triangle is clearly a right angle triangle. Therefore, the triangle is right angled. Option 3 is the right answer. Option 3 is the right answer. If D1, D2, D3 are the diameters of three ascribed circles or X circles of the triangle, then D1, D2 plus D2, D3 plus D3, D1 is equal to first option delta square, second option 4S square, third option 4 delta square, fourth option AB plus BC plus CA. D1 is equal to 2R1, D2 is equal to 2R2, D3 is diameter of the third ascribed circle or X circle. So, D1 we have this. What is D1 D2? Sigma D1 D2, we will write it as D1 D2 plus D2 D3 plus D3 D1 can be written as sigma D1 D2, that is equal to 4 into sigma R1 R2. Okay. Let us observe that sigma R1 R2 is equal to in fact S square. This is one result. This has to be borne in mind. We will prove it also. 1 by R1 plus 1 by R2 plus 1 by R3 is equal to 1 by R. Let us observe this. First observe that 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R is R. Now, from here, it is a simple thing to observe. This is also a standard result. And also, we have already observed that R into R1 into R2 into R3 is equal to delta square. Okay, here, when you let's come back to this result. What do we have in the numerator? We are going to have R2 R3 plus R3 R1 plus R1 R2. So, that is sigma R1 R2 by R1 R2 R3, that is equal to 1 by R. Let us multiply both sides with R in the denominator. Let us multiply. So, what do we have here? We have therefore sigma R1 R2 divided by R into R1 R2 R3 is equal to R into R1 R2 R3 is equal to your 1 by R square. So, this R into R1 R2 R3 we already know that it is delta square. So let's pull that side. So we have therefore sigma r1 r2 to be delta square by r square, which is nothing but s square. So therefore sigma r1 r2 is equal to s square. This is also an important result that has to be borne in mind. So sigma r1 r2 is s square. Sigma 1 by r1 is equal to 1 by r into r1 r2 r3 is equal to delta square. These are the four results that we need to keep in mind. So here what is sigma d1 d2? That comes out to be 4 into sigma r1 r2, that is 4 into s square. What is s here? S is the semi-perimeter. S being semi-perimeter. Therefore, clearly the option 2 is the right answer. Option 2 is the right answer. Let's move on to the next question. In a triangle ABC, if R1 is equal to 2R2 is equal to 3R3, then A by B plus B by C plus C by A is equal to, where ABC are the sides of the triangle opposite to the vertices capital A, capital B, capital C, is equal to, first option 75 by 60, second option 155 by 60, third option 176 by 60, fourth option 191 by 60. What are we given? R1 is equal to 2R2 is equal to 3R3. So let's write the formula for R1, R2, R3. So delta by S minus A is equal to 2 into delta by S minus B, and that is equal to 3 into delta by S minus C, this 3 there. Now this delta can be cancelled throughout. What do we have here? 1 by S minus A is equal to 2 by S minus B is equal to 3 by S minus C. By ratio and proportion, you could multiply each of this fraction in the numerator and denominator by some multiplier and add up all of them. So what you do is, you just add up here 1 plus 2 plus 3 divided by S minus A plus S minus B plus S minus C. This is by ratio proportion here. That is, therefore 1 by S minus A comes out to be 2 by S minus B, and that is also equal to 3 by S minus C, and each is equal to 6 by 3S minus A plus B plus C. What is A plus B plus C? 2S. So what do we have here? 3S minus 2S, and that makes it 1 by, so that is 6 by S. 6 by S. So we have therefore S minus A by, let us equate the first and the last. S minus A by S is equal to 1 by 6. Similarly, S minus B by S is equal to 2 by 6. And S minus C by S, S minus C by X is equal to 3 by 6. So from here we can say that 1 minus A by S is equal to 1 by 6. From here 1 minus B by S is equal to 2 by 6, and 1 minus C by S is equal to 3 by 6. So clearly A by S will be 5 by 6. 1 minus 1 by 6 will be A by S, that is 5 by 6. And what about B by S? That's going to be 1 minus 2 by 6, that is 4 by 6. And what about C by S? C by S will be 1 minus 3 by 6, that is again 3 by 6. What you wanted was A by B plus B by C plus C by A. What is A by B from here? A by B will be 5 by 4. SS will cancel and we'll have 5 by 4. What about B by C? B by C will be, what is B by C? 4 by 3. What about C by A? C by A would have been this divided by this, that is 3 by 5. So we just need to add up all these three now. A by B plus B by C plus C by A is what you require. So 5 by 4 plus 4 by 3 plus 3 by 5. So LCM is clearly 60, and we have 15 into 5, 75 plus 20 into 4, 80, 80 plus, and we have here 12 into 3, 36. Okay, so 155 plus 36, 191, 191 divided by 60. So that's clearly the answer 4. Option 4 is the right answer. Option 4 is the right answer. So let's get back and see what we have done here. R1 is equal to 2R2 plus R1 is equal to 2R2, and that's also equal to 3R3. We just use the formula, and here this is the main step here. We just manipulated like this. We use the ratio proportion. We use the multipliers 1 1 1 here, added up. So we got 1 plus 2 plus 3 by this thing. That gave me 6 by S. So that gave me A by S, B by S, and C by S. And using all of them, I found out A by B, B by C, and C by A. Adding up all of them, we're getting 191 by 60. Therefore, the option 4 is the right answer. Let's move on to the next question. Question number 4. 4 into capital R into small r into cos A by 2 into cos B by 2 into cos C by 2 is equal to R2 plus R3 into secant square A by 2. Second option, R1 into R2 into R3. Third option, delta. Fourth option, small s. Now, the radius in radius is given by the formula 4R sin A by 2 sin B by 2 sin C by 2. In radius is given by, this is the circumradius, R is the in radius, that's given by this formula. So now let's have, we are asked to find out 4R capital R. So what is 4 capital R into small r? That's going to be 4R into this 4R sin A by 2 sin B by 2 sin C by 2. Okay, that now 4R R into cos A by 2 cos B by 2 cos C by 2 is what we require. What will that come out to be? You'll have to multiply by cos A by 2 cos B by 2 cos C by 2. So that gives me, what we'll do is we will pull out that R from here. 4 into 4 is 16. We will write this as 2R square into 8 sin A by 2 sin B by 2 sin C by 2 I just further multiplied by this cos A by 2 cos B by 2 cos C by 2. So we'll have that cos A by 2 cos B by 2 cos C by 2 here. Now to club these two things we require a 2. 2 sin A by 2 cos A by 2 will be sin A. 2 sin B by 2 cos B by 2 is sin B. 2 sin C by 2 cos C by 2 is sin C. So we'll split this 8 into 2 cube and then write this as 2 sin A by 2 cos A by 2, 2 sin B by 2 cos B by 2, 2 sin C by 2 cos C by 2. So now we have 2R square into sin A sin B sin C. Okay, 2R square into sin A sin B sin C. Yet again this is another formula which is nothing but delta. That the area of the triangle is also given by the formula 2R square sin A sin B sin C. It is also given by, delta is also given by ABC by 4R. That ABC by 4R and 2R square sin A sin B sin C will be the same, because you can use the sine rule here. A will be 2R sin A, B will be 2R sin B. Let me demonstrate. 2R sin A into 2R sin B into 2R sin C divided by 4r. What is that going to be? Clearly, it is 2r square sin A sin B sin C. So, okay. Right. So, this 2r square sin A sin B sin C is actually delta there. But then this is also an important formula that you need to remember. It actually comes from here, delta, the area of the triangle, I can say is given by, this is small c and small b. Half BC sin A gives us the area. Okay, half BC sin A. How is that? Just look at this. You draw an altitude from B. What is that going to be? C sin A. This will be C sin A. So, half of the base into height, that gives us the area of the triangle. So, half BC sin A is your delta. But then the sin A can be replaced by A by 2r. So, we will then have ABC by 4r. So, A by 2r, sin A is A by 2r, BC by 2, that is your delta. So, half BC into delta A by 2r, that makes it ABC by 4r. So, we can actually prove this. These are all important results. Anyway, come back to this where we started with. This is an important formula that you need to remember. Small r is equal to 4r sin A by 2, sin B by 2, sin C by 2. And this is also a formula that can be remembered, but this is more important. These two are interlinked here. And how is delta? Half BC sin A. Okay, so it has come from here. This formula came from here. All right, therefore, they are all interlinked. And we have the option, clearly, the option 3 is the right answer. Let's move to the next question. Fifth question, small r into cot B by 2 plus cot C by 2 is equal to, first option A, second option B, third option C, fourth option 0. Now let's recall r is equal to delta by S. But the delta by S, we can even write this as S minus A into tan A by 2, because we already know that delta by S into S minus A is equal to tan A by 2. So here delta by S. Similarly, delta by S into S minus B is tan B by 2. Therefore, this is also can be written as S minus B into tan B by 2. This will also, one more way to write it is S minus C into tan C by 2. So very clearly, if you transpose this tan A by 2 to the other side, we get r cot A by 2 to be equal to S minus A. R cot B by 2 is equal to S minus B. And r cot C by 2 is equal to S minus C. So what are we adding up? We are adding up these two things. So what do we have then? We will get r into cot B by 2 plus cot C by 2 to be equal to, from here we have this to be equal to S minus B plus S minus C, that is 2S minus B plus C. But what is 2S? 2S is nothing but A plus B plus C. A plus B plus C minus of B plus C, that is very clearly A. So what is the right option? The right option is, option 1 is the right option. Question number 6. If in the triangle ABC, S minus A by delta is equal to 1 by 8, comma, S minus B by delta is equal to 1 by 12, comma, S minus C by delta is equal to 1 by 24, then B is equal to, first option 16, second option 20, third option 24, fourth option 28. We know that delta by S minus A will therefore be equal to 8. Delta by S minus B is given to be 12. Delta by S minus C is given to be 24. So this is R1, R2, R3. Now we know that 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So from here, your 1 by R will be equal to 1 by 8 plus 1 by 12 plus 1 by 24. You can take out 24 will be the LCM. We have here 3 plus 2 plus 1. That makes it 1 by 4. So R is equal to 4. So this is 1 in radius has been found to be 4. Now what else we know? We know that R into R1 into R2 into R3 is equal to delta square. So that makes it 4 into R1 is 8, R2 is 12 and R3 is 24. 24 here is delta square. So what is delta from here? Delta square, you observe that this can be written as we'll take out a 2 common here. We'll write this as 12 into 12 into 2. This 2 into 4 can club it and makes it 8, 8 square into 12 square. So delta square is 8 square into 12 square. So what is delta? 8 into 12, that is 96. So we have here delta to be 96. Now what we required was B, that B can be availed from here. Delta by S minus B is 12. So if I can find out S, since I have already found out delta, I can get the value of B from here. So now, but then we have to find out S. So how do we find out S? There is one more formula which links up the semi-perimeter with the X radii. What is that? Sigma R1 R2 is equal to S square. We can use this formula. What is sigma R1 R2? 8 into 12 plus 12 into 24 plus 24 into 8. That is our S square. So clearly we can take out a 12 common. Here we have 8 plus 24 plus 8 into 2, 16. Okay, so that is S square here. So 24 plus 24, 48. So 12 into 48 it is your S square. So that I can write it as 12 into 12 into 4. So that is your S square. So S is equal to, S is 2, 12 into 2, that is 24. S is 12 into 2, that is 24. So we have here 24 minus B to be equal to delta by 12, that is 96 by 12, that is 8. So B is therefore 24 minus 8, and that is 16. So B value is 16, and that's clearly appearing in the option 1. Option 1 is the right answer. Here, let's observe one thing. We had R1, R2, R3. Okay. So 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So I have written that 1 by R and got the value of R. And now I am multiplying with R into R1, R2, R3 is delta square. That's in the formula. So delta comes out to be 96. So sigma R1, R2 is S square. That gives me S to be equal to 24. Now use that S and delta from here in this equation and get the value of B. That's what you wanted. So B is equal to 16, and option 1 is the right answer. To the next question, question number 7. In a triangle ABC, A is to B is to C is equal to 3 is to 5 is to 4. Then A plus B plus C root 2 is equal to first option 3A, second option 3C, third option 3B, fourth option 2C. Okay. Now we are given that A is to B is to C as the angles are 3 is to 5 is to 4. Okay. Now that makes it A will be 3 by 12 into 180. The total is 12 there, 3 by 12 into 180. That is 45. B is 5 by 12 into 180. 180 by 12 is 15, 5 into 15, that is 75 degrees. And angle C will be 4 by 12 into 180, which is equal to 60. 1/3 of 180, and that's equal to 60 here. So angle A is equal to 45 and angle B is equal to 75, and we have 45 here, B is 75 and C is 60. That's how the angles are. That's how the triangle is. Now this is our A, small a, and this is our small b, and this is our small c. We know that by sine rule, A is equal to our sine 45. So that makes it 2r by root 2. B is equal to our sine 75. What is sine 75? Root 3 plus 1 by 2 root 2. And small c is equal to, now the c value is equal to 2r sine 60. And let's write what is a plus b plus c root 2. That's going to be 2r taken common. A is 1 by root 2 here, 2r into 1 by root 2. What about b? Root 3 plus 1 by 2 root 2. And what about c root 2? That is going to give me sine 60 is root 3 by 2. So we have here root 3 by 2 into root 2. So that into root 2. So that gives us 2r into root 3 plus 1 by root 2. This root 2 and this 2 will cancel, and we have here, we can club these two terms here, and we have therefore root 3 plus 1 by root 2, and here root 3 plus 1 by 2 root 2. Now, can we write this as, this is our 2r into root 3 plus 1 by root 2 can be taken common, and we have here 1 plus 1 by 2. So that makes it 3 into 2r into root 3 plus 1 by 2 root 2. We have a 3 by 2 here. I am pulling that 3 out, taking this 2r here, and what is this equal to? 2r into root 3 plus 1 by 2 root 2. What is that equal to? B. So this is coming out to be 3b. So what is that? A plus b plus c root 2 turning out to be 3b, and that's clearly appearing in the option. Option 3 is the right answer. Option 3 is the right answer. Let's move on to the next question. If a square comma b square comma c square are in arithmetic progression, then cot a comma cot b comma cot c are in arithmetic progression, second geometric progression, third harmonic progression, and fourth arithmetico-geometric progression. Now, what's the relation between the sides and cotangents of the angles? Let's have a look at this. Cot A is equal to cos A by sin A. We can use the cosine rule formula for cos A. So, what do we have here? B square plus C square minus A square by 2BC sin A. But this 2BC sin A can be written as 4 delta, because half BC sin A is equal to delta. So, 2 into BC sin A, we can write this as 4 into half BC sin A, and this is B square plus C square minus A square here. This half BC sin A is delta, so what do we have? B square plus C square minus A square by 4 delta. Similarly, cot B will be equal to C square plus A square minus B square by 4 delta. So, when you have a here, we have negative term with A square. When you have a B here, we have negative term with a small b square. Cot C will be A square plus B square minus C square by 4 delta. That is, so now how do we think we can get these quantities? Using A square, B square, C square. A square, B square, C square are in arithmetic progression. If you multiply each term of a sequence which is in arithmetic progression with some number, it still turns out to be in arithmetic progression. Even if you divide also, it's the same. So, what we'll do is, we will multiply by 2 by A square plus B square plus C square. Multiply each term with this. Multiplying by 2 by A square plus B square plus C square. What do you get? 2A square by A square plus B square plus C square, comma 2B square by A square plus B square plus C square, comma 2C square by A square plus B square plus C square. Will it again be in AP? Yes, it will be in AP. So, it is again in arithmetic progression. So, what do we have here? That is, we started with A square, B square, C square to be in AP. If you multiply by any constant, the resulting series will also be in arithmetic progression. So, what we will do is, now how do we obtain these things? B square plus C square minus A square expression. What we will do is, we will subtract, we will multiply by a minus sign, that will still be in AP. We will add a 1 to each of them. So, 1 minus 2A square by A square plus B square plus C square, comma 1 minus 2B square by A square plus B square plus C square, comma 1 minus of 2C square by A square plus B square plus C square. All these three quantities will still be in AP, arithmetic progression. But what is this coming out to be? This turns out to be B square plus C square minus A square by A square plus B square plus C square, comma again C square plus A square minus B square by A square plus B square plus C square, comma here we will have A square plus B square minus C square by A square plus B square plus C square. Now, what I will do is, now how do we think we can get this now? You multiply throughout by A square plus B square plus C square and divide by 4 delta. So, multiplying by A square plus B square plus C square by 4 delta, throughout you multiply with this. Then what do we get? If you multiply each term with that, we will get cot A here, and cot B here, and cot C here. Observe that if you multiply with A square plus B square plus C square by 4 delta, This a square plus b square plus c square will cancel, and you will be getting b square plus c square minus a square by 4 delta, which is nothing but cot A. Similarly, cot B here and cot C here. So what is it we are able to observe? These are also in AP. Therefore, cot A, cot B, cot C are in arithmetic progression. So that is clearly appearing in the option 1. So option 1 is the right answer. Let's move to the next question, question number 9. A dash, B dash, C dash, comma ABC are two triangles such that A plus A dash is equal to 180 and B is equal to B dash. Then first option, A dash is equal to B dash plus C dash. Second option, AB dash is equal to BA dash plus CC dash. Third option, A dash B is equal to B dash C plus C dash A. Fourth option, BC dash is equal to B dash C plus BA dash. Now we have two triangles ABC. And another triangle A dash, B dash, C dash. The sides opposite to ABC, we'll write them as small a, small b, small c. And the sides opposite to A dash, B dash, C dash will be written as A dash, B dash and C dash. Okay. Now, we wanted a relation between A dash, B dash and C dash from here. So, angle A and A dash, what is angle A dash? 180 minus A. Angle B dash is same as angle B. These two are equal. So, this is B. So, obviously, this in terms of A and B can be found out. What is C dash? C dash will be equal to, the angle C dash will be equal to, angle C dash is equal to 180 minus A plus B. So that makes it A minus B. That makes it A minus B. So this angle C dash is actually A minus B. This turns out to be A minus B angle. Let's use the sine rule and write the values of the sides in terms of the angles. What is it? A is equal to, let us assume that the circumradius of this is R1 and the circumradius of this is R2, circumradii is R1 here, circumradius for this triangle is R2. What is A here? 2R1 sine A. What about A dash? Let's call it 2R2 sine of 180 minus A. That's again sine A only. So that is 2R2 sine A. 2R2 sine A. What about B? 2R1 sine B. And what about B dash? B dash is the side opposite to this angle angle B dash, which is same as B. So what is that? 2R2 sine B dash, which is nothing but sine B again. Okay. What about C? C is equal to, this is 180 minus of A plus B. 180 minus of A plus B. So I can write it as 2R1 into sine of 180 minus of A plus B is nothing but sine of A plus B. So we will write it as sine of A plus B. What about C dash? 2R2 into sine of A minus B. Now we wanted a relation between A dash, B dash and C dash here. Now let's observe that if you look at A dash, that is 4R1 R2 into sine square A. B dash is 4R1 R2 into sine square B. And what about CC dash? CC dash is equal to 4r1 r2 into sine of a plus b into sine of a minus b. We have a formula, sine square a minus sine square b. Sine square b. So what is that? We use the formula sine of a plus b into sine of a minus b is equal to sine square a minus sine square b. This is a formula that has to be memorized. Sine of a plus b into sine of a minus b is sine square a minus sine square b here. So now, okay, that's very clear that we have here, this is 4r1 r2 sine square a is a dash, 4r1 r2 sine square b is bb dash. So we have therefore a dash is equal to, let's transpose this bb dash this side, bb dash plus cc dash. Okay, so therefore that is clearly appearing in the option 1. Option 1 is the right answer.